Welcome back. Today we're going to talk about the law of cosines. The law of cosines, like the law of sines, has three specific forms. At first it's going to seem like the law of cosines is much more difficult. It does have some other elements, but there are some advantages that we're going to talk about in just a minute. The law of cosines, the three forms, just like the law of sines, they follow a regular pattern, and we're going to see what that looks like in just a minute. Okay. We're going to assume we have a triangle that's labeled in the regular way. So that means we'll have A and B and C, which means that A is across from A, B is across from B, C is across from C. So little letters are for the sides and big letters are for the angles. And our law of cosines looks three ways. A squared equals B squared plus C squared, vaguely Pythagorean. But then we have to account for the fact that it's not a right triangle, so minus 2bc cosine of A. Notice a couple things. I've got A on the ends, and then everything in the middle is the B's and the C's. Next form. B squared equals A squared plus C squared minus 2ac cosine B. Okay, so again, B's on the ends, and then I've got A squared plus C squared, so the other two, and then times 2ac. Third form, you could probably guess it by now, is equal to A squared plus B squared minus 2ab cosine C. So what's the trick to using the law of cosines? Well, you got to look at what you've got. And so when I go down here, check out what I've got. I've got an A and a B and an angle C. So we're going to solve this triangle. Solving the triangle means the 6 parts. So what am I going to use? Well, I've got to make a decision here at this point. And my decision that I'm going to make is based on the fact that I need all 6 parts. So A equals, B equals, C equals, and then A equals, B equals, C equals. So this is 20 degrees, and 11, and 5. And so I need to pick the form that's going to give me the least number of things to solve for. Well, check it out. I've got A and B for sides. And then C. So if I was going to pick this one, I'd use A and B, but then I'd have C open, but I'd also have angle B open. If I pick this one, I'd have A and B, but I'd have C open, but I don't have A. But if I look down here, if I use this form, I'd actually have C squared, which I don't know, is equal to 11 squared plus 5 squared minus 2 times 11 times 5 times cosine of 20. Check that out. So now I only have one unknown. So the game for this one is kind of figuring out, okay, which pieces do I have and how do I use those pieces to pick the right ratio to solve for. When I solve this down, there's a couple of important things that are going to happen here. And you kind of have to keep track of it, especially when we start to solve for an angle and use inverse ratios. Let me just erase here a little bit. Minus 2 times 11 is 22 times, so 22 times 5 would be a 110 cosine 20. Now notice, I can now plug this into my calculator, right? And I'm going to take the square root. So when you plug this into your calculator and take the square root, so I get square root of both sides, I'm going to end up with C is equal to 6.53. Okay, so I plugged all that into my calculator. I got C is equal to 6.53. At this point, I have choices, right? Because now you're thinking, well, you could switch over to the law of sines, right? Because you said you have to have a full ratio. So I've got this side C, and I've got C equals 20. One cautionary tale. You could use sines or cosines. But like what we've talked about, sometimes when you use the law of sines, because of its because the arc sine function, when you work backwards, its range is only 0 to 90. And so if we've got some angle that's outside of that, an obtuse angle, it's going to eliminate. So we want to use the law of cosines because it accounts for obtuse angles. Okay, we want to use the law of cosines again because it accounts for those acute angles, or those obtuse angles. So what does it look like now? Now, because I have A, B, and C, I can use any of the forms. And so I'm just gonna go right down the line. Here we go. So A squared equals B squared plus C squared minus 2BC cosine of A. And because I have all three sides, I can just go ahead and plug it in. 11 squared equals 5 squared plus 6.53 squared minus 2 times 5 times 6.53 cosine of A. And I've got to solve. So I'm going to subtract, all of this. From both sides. Squared. And so what I've got is 11 squared minus 5 squared minus 6.53 squared is equal to negative 2 times 5 times 6.53 cosine of A. Okay, so all I did was I subtracted the stuff I was adding. This is solving an equation now. Now I need to divide by this business here. 2 times 5. And you're probably like, well, why doesn't he just calculate? I'm going to show you, this is a little shortcut that we can use in the end when we figure out what exactly we're doing. Negative 2 times 5 times 6.53. So look at what I've got here. All of this is now gone, and this is equal to cosine of A. And so what's my answer? Now I'm going to take the inverse cosine of all of this. So it's the inverse cosine of everything subtracted divided by the part I was multiplying by. That's the shortcut. And so when I put this into my calculator, I need to make sure that I put my parentheses on top here and a parentheses on bottom here. And when I take that inverse cosine, it's going to give me angle A. And when I do it, I plug it into my calculator, I get that A is equal to, so the measure of angle A is equal to 144.80. Okay, so what does that mean? Well, that means that I now have this one, and I have my C equals 20. So to find my third angle, I'm going to do 180 minus 144.80 minus 20, and that's going to be equal to 15.20 degrees left over. Okay, which is awesome because now I have all 6 parts. So I use the law of cosines to determine one of the angles. So I use the pieces that I had to determine a side in this case. And then I use the law of cosines again using that new information to find an angle. So there's an element of solving for a C here and also maybe using the inverse cosine to find an angle. So what's the case here? If we drew this picture, just to check it out, we would see A, B, C. So opposite of A would be 11, opposite of B would be 5, and C would be 20. This is the side angle side case. So we can definitely use this in the side angle side case, but also we can use it in the side case, which is what this next one involves. So check it out. So I've got A, B, and C. And so A is 9. That is definitely not A. You're probably sitting out there going, that's not A. A is 9, B is 7, and C is 5. Well, notice, when I look at my 3 formulas, what's going to happen? A, B, C, B, C. I'm going to end up with all cosines. And so that's where this trick here that I just showed you, where you can subtract everything and divide by the whole product in front of the cosine, that's going to be helpful here. So let's take a look. Let's set up the first one. A squared equals B squared plus C squared minus 2AB BC 2BC cosine of A. So if I fill in everything I know, I've got 81 equals 49 plus 25 minus 2 times 7 times 5 times the cosine of A. And so I've got 81 minus 49 minus 25 divided by, so I subtracted both of these, and I'm dividing by this whole product here, minus 2 times 7 times 5 is equal to the cosine of A. So yeah, you can solve it like a regular equation, just kind of showing you a little shortcut here. This is also how they do it in your books. I'm trying to show you where they got that from. So when I do this, I'm doing the inverse cosine. And the inverse cosine of this whole mess. So I'll do 81 minus 49. (81 minus 49 minus 25) is 7. And this is negative 70, so I actually have the inverse of negative 1/10 is going to be equal to, now make sure your calculator's in radian or in degree mode here, and that's going to be 95.74 degrees. Okay, so that's one of my angles. Remember, I'm solving for all 6 parts. Let's do it again. So which one do you want to pick? Well, I'm gonna just go straight down the line. B squared equals A squared plus C squared minus 2AC cosine of B. Let's fill them in again. 49 equals 9 squared plus 5 squared minus 2 times 9 times 5 times the cosine of B. So I'm going to subtract all this. So 49 minus 81 minus 25 divide by this whole piece here. Minus 2 times 9 times 5 equals the cosine of B. So this is going to be cosine inverse of this whole side, which is negative 57 over negative 90 is equal to B. And so B is going to be equal to 50.70 degrees. And so now I have one angle, I have two angles, so C is equal to 180 minus 95.74 minus 50.70, which is going to give me 33.56 degrees. So 1, 2, 3, 4, 5, 6 pieces of information. That's law of cosines, okay? So either you've got the side angle side case where you're going to use law of cosines again, or you're going to use the side, you're going to have the side case where you do one whole one and then you do another whole one using the information that's given from the 3 sides. All right, the other piece of this, and this is a little bit less, this is a little bit shorter. There's an area of a triangle in 2 ways. The first one, triangle area is equal to this. This is actually a pretty cool little deal. 1/2 BC cosine of A, no, sine of A. Got law of cosines in the brain. So if I do 1/2 BC sine A, I could also do 1/2 AC sine B, or 1/2, and you see how this goes, AB sine C. So that's one way we could do it. Okay, that's triangle area. The other way that we could do it is a formula called Herons formula. And Herons formula involves something called semi-perimeter. Well, semi means half, so like, you know, semi-annually or semicircle. So the semi-perimeter is the perimeter divided by 2. So I take all 3 sides, divide by 2. And Herons formula says that the area of a triangle area equals the square root of, and actually I should note this, semi-perimeter is going to be equal to S, little s. The semi-perimeter times the semi-perimeter minus A times the semi-perimeter minus B times the semi-perimeter minus C. Okay, so there's 2 ways to find area here. We're going to do 2 examples. One's going to be with this shorter little formula. One's going to be with the semi-perimeter formula. Find the area of the regular pentagon inscribed inside of a circle of radius 9 inches. And this should actually be octagon. Okay, we'll make this an octagon, which means it has 8 sides. Well, what does it mean to find the area, that's everything inside, and what does it mean to be inscribed inside? If I have an octagon here, right? 8 sides. It's regular, which means all of the sides are the same length. And it's inscribed inside of a circle, which means all of these points touch the circle. And what it's telling me is it has a radius of 9. So from each of the corners to the center is 9. 9. 9, 9, 9, 9, 9, 9. I'm going to pull out one of these triangles just to show you. This triangle here, it looks like this. And each of these is 9. 9. Okay? And it's regular, but we don't necessarily know what this side length equals. But nonetheless, let's think about what this means. If we're trying to find the area of this, is there a way to know an angle? This angle, perhaps. Because if I label this, A, B, C, I don't have little a, but I do have B and C. Inside of any polygon, all the way around, is 360 degrees. But if there are a number of wedges, a number of pieces of the triangle, how many are there here? There's 8. So each of these, because it's regular, is going to be equal to the same amount. So I'm going to take that 360 all the way around the middle and divide by the number of triangles that are present. And I'm going to get 45, which means that this is a 45 degree angle. Well, what does that do for us? Notice, if I need 2 sides and the angle between them to use this formula, what I'm going to say is my area is equal to 1/2, and it's going to be B, C, times the sine of A, the angle in between them, sine of 45. And all I've got to do is plug that into my calculator. Why does this work? Well, because the radius of the circle goes to each edge, and so I'm left with a triangle that has 2 sides, and then the angle between them can be found by dividing by 360. When I do this formula, I plug it into my calculator, I get that the area of this triangle, or the area of this triangle, 0.5 times 9 times 9 times sine 45 is around 28.637 units. But I'm not trying to find the area of that triangle. What am I trying to find the area of? I'm trying to find the area of the whole thing. And so what I really need to do is, that's my triangle area, my octagon area is actually equal to 8 of those times 1/2 times 9 times 9 times sine 45. So this is a rounded value. So if I asked you the area of the triangle, you could say, okay, I can round that value. And so to find the area of the octagon, I multiplied the triangle times 8, and that gives me that my area of my whole figure is about 229.10 inches squared. All right, the last one's easier. I'm finding the area. I have 3 sides. That's Heron's formula. So my semi-perimeter is 13 plus 15 plus 18 divided by 2. And that's going to give me 28 plus 18 would be 46, so that's going to be 23. So my semi-perimeter is 23. And so my triangle area is the square root of 23 times 23 minus 13 times 23 minus 15 times 23 minus 18. So square root of 23 times 10 times 8 times 5 is going to be equal to the square root of 9,200, which is approximately equal to 95.9 units squared. What does it mean? Well, that was a lot easier than having to divide, but you have to go with the information that you have. So we had a side angle side case, which was our where we used our 1/2 AB cosine C. And then we have the side case where we can find the area knowing the three sides and using Heron's formula. All right, guys, that's all there is to it. Thanks for watching, and we'll see you next time.